let's go to Liquor 3372 maximize the number of target nodes after connecting trees. So it gives us two trees, age is 1 and age is 2. And there is a K. So the thing is that for this kind of two trees, right? So the thing is that for example, tree 1, tree 2, and tree 2, um, we can connect any node. Um, so that's the thing is that for every node we can connect once. When we query how many nodes the count, for example, this is node 0, right? How many nodes in the tree one which has distance smaller equal to k, right? And also we can connect any when we can have a connection between any nodes with between any nodes from tree one and tree two, and we should also add those kind of nodes which is also small, has a distance when we connect smaller than when we add this one, right, that is smaller than k from tree two to the result. So one thing we can think about is that if we query, for example, tree node 0, right? So the connection from tree 1 to tree 2 should always coming from the node we are querying, right? Otherwise, if it is from a different node, it's not efficient. There is another distance, right? So that will add the total distance. And for those kind of, so for the tree 2, what we want is that we want to get the maximum. We can iterate from every nodes, find the nodes which have the max counts, which is smaller than k minus 1, right? So from that node, if for example this one has counts which is greater than the other nodes, then we can have this one connect to the one we are querying. So what we do is that we use a DFS or BFS for every node in tree one to find how many the counts of the other node which smaller equal to k, right? And then in tree two, we can do the similar thing, but we just need to find that is smaller than count smaller equal to k minus 1, right? Because when we connect from tree one and to tree two, we'll add one more edges. So we just find the maximal nodes, which nodes has the maximal count smaller equal to k1, right? And in the end, we just add this count to every node which have we query the result. So that will be our final result. So let's code for this. Let's write code for this. So um, going to have at least integer. Um, use this one as tree one equals, for example, let's have a function called make tree. Age is 1, right? And also we can have tree equals make tree age is 2, right? So what we do is that we're going to have a result equals so what we do is that we can um, also have function called get count, right? So for this one, we pass in tree one and count it. That will be the distance is smaller equal to k, right? In tree one, and also we can have answers, which we can reuse this function get count, right? We use tree two, but now we just want to use get distance k minus 1, and the final result, right? We should use this array, but for the result from tree two, we just want to get the maximal, right? And add to this every element of this result. So what we do is that um, we should have max from which should be coming from from the tree two, right? Um, so let's set this one as 0, right? So for int v in answers, then we need to get the maximum one. That's why it's max equals to max dot max v. And in the end, right? So what it is that for int I equals to 0, I smaller than result dot length I plus plus. So we're going to have a result I, which is plus equal to max. In the end, just a return result. So we need first function is that we need to create a private list integer we call make tree, right? Make tree, make tree, and we pass in the ages. So we're going to have in a equals ages dot length plus one, right? And then we're going to have a list integer tree equals new list, right? So arrays set of tree L equals to new array list. Then what we do is for every age in ages, we're going to have a tree age 0 should add age 1, right? And also we need to have the age 1 at age 0. And in the end, just a return tree. So this will be the make tree, right? And also we need to get counts. Get counts will be so we needed to for from each node trying to DFS or BFS whatever, right? Await int it count because for example we have list of integer tree, right? We need a distance limit to be hit, right? So int n equals tree dot length. Then we're going to have int result equals new int n. So for int I equals 0, I smaller than I plus plus. So now we can do whatever BFS or DFS, right? Let's do DFS equals new int 1 and DFS tree from current node, and its parent is -1, right? And also this will be the length, right? Because we need to have the length. Current length is 0. We need to have length to be limited to k, right? And also count. So we're going to have result I equals count 0 and the return result. And then we write DFS private void DFS. So we need DFS tree, right? Integer tree into current, into parent, into length, right? Into limit, into count. So what we do is that if length is small equal to k, then we're going to have count 0 should increase by 1, right? And for array next in tree current, then if this is next is the parent, right? We should continue if next equals parent. We should continue. Otherwise, we just narrow DFS to the next level. DFS tree next parent length to the +1, right? Okay, count. So this will be the code. Mhm. It will be O n squared plus m squared time complexity. And also the space will be OM plus N, right? So let's also write a Python code for this. Should be very similar. Um, so we need define several functions, right? So we have tree1 equals self dot make tree make tree age is 1, and tree2 equals self that make tree age is 2, right? And then what we do is that results should equals self dot uh, get count tree 1 k, and and also answers equals self dot get count tree 2 k minus 1. Okay. Then what we do is we need a maximal value, right? Maximal value equals max answers. And for I in range length results, so we're going to have results I should plus equal to max rate, right? And then in the end, just a return result. So this will be the main and define the make tree uh, self ages. So what we do is that n equals the length of ages plus 1, right? Tree equals this one or this one in range. Okay. Then for UV in ages, then tree U should append the V, right? And also tree V should append U. And then what they do is that just return tree. So this will be the first function, right? And also we need a get count, def get count. So we need a self tree here, right? So we can do this will return our array. All right. So we'll have n equals length tree, and then we're going to result equals this one multiply n. Then for I in range n, right? Then we're going to have count 0. Uh, yeah, we count. Which pass by should pass we still pass by reference. Okay, so self dot DFS tree I parent is -1 and current length is 0 and limit k count, right? So then we'll have result I equals count 0 and then return results. Then we need to define the DFS. TFS. So we should have a self and the tree, parent, length, and k and counts. Then let's say if length is small equal to k, right? Only in this case we can have count 0 increased by 1. Then what we do is that for next in neighbor. neighbor in tree parent, right? If name equals parent, so should continue, right? And then we should have self DFS tree neighbor parent events should plus one, right? Okay, and count make tree. Let's get this on the capital. Okay.